All right. Uh, so what we are going to discuss today. First of all, this is our session about Docker with Selenium Grid, and it's very new concept. It's very as compared to traditional way of testing, and it's becoming very famous among the developer community, among the testers community, and being used and and encouraged actually worldwide. So what this is about, what is Docker? Some of us are new to Docker, some of us who are already aware of it, but still want to get a gist of what they can also improve. This session is about that. So what is a Docker? So Docker is a containerization platform. It gives you the possibility to run more applications on same hardware than other technologies. So what does that mean? So let me show you instead of explaining. So you must be familiar with the concept of VirtualBox, VMs or machines. what what is the difference between a Docker container and a VM machine? So the main difference, as you can see, this is my VirtualBox manager. And if you take a look on the right, there are some specifications, and which tells me that this particular VM takes exactly this much of my memory here, this much of my resources. And at some point, if I run like 4 or 5 of the VMs, heavy VMs, then my computer is gonna go crazy. It will slow down. The processes will slow down because the memory or the RAM utilized by these VMs is going to consume because they need a dedicated memory, right? So you cannot use that. You can, let's say, if I see my machine currently, so how many CPUs I have? I have around 8 cores in my machine, and the VM is telling me that I need one of them or two of them uh, to run my processes, and that means that it is a heavy resource consuming tool, and it will not scale on a single VM, on a single machine. And that's where the container outsmart the virtual machines. So how do that do that is it's not a virtual machine, first of all. So the second point in the slide, that is, it uses same underlying processes. So you can assume like opening any application on your host machine itself, and it also uses some process, and the containers are also the similar processes. They are not dedicated to utilize some of your resources. So that's the main underlying difference between the containers or Docker containers and virtual machines. Now, what is containers, what is images, or whatever the concept is, we are going to talk in this session. I'm going to cover basic of what they mean, but you can also jump on. There is a lot of content, static content out there on Google. You can just search with Docker and you get a lot of content. But we are going to see the practical application of it in this session. So what is a container? First of all, it's a minimum set of environment required for your application to run, to execute. So what is that? As you have already seen here, this particular VM is asking me to provide it this static resources, right? But container is not like that. Container, you can you can configure them depending on the minimum required resources, and they will only use those resources. They will not ask for more. If you say like, because if you see here in this dev machine or in the VM, it is using these two adapters for some reason, and on my container only requires one network or one particular container. So it will not block your other resources for using that particular. Or let's say here it is using 2 ports, but my container can only use 1 port, right? Of course, sometimes it will use 2 ports of your machine. So that is pretty much networking concepts. But why Docker. Why containers? Because it takes less space and memory on your machine, and that is way important than if you work heavily on your applications, on your testing, and you want to execute a lot of processes at some point of time, you will hate virtual machines. So there are some basic commands when using Docker and how to install it. First of all, to install Docker, you can go to Docker Hub. If you are on Mac and Windows, you can directly install via this button, and it will install Docker Desktop on your machine. So what it will install? It will install a daemon. So that daemon is a process which is going to listen. So this whale icon, what you are seeing right now on my machine, is the daemon process, which is listening to client. What is the client? Client is this binary. Uh, so with this binary, when you install the Docker desktop, it will get installed in your machine as well. So what it will install, first this binary, second this daemon, and now you are configured to talk to remote resources to pull the images. How does this work? How does this Docker system works? You might have heard of a concept of Docker Hub. So if you just Google it, so here on Docker Hub, it's a cloud where you push your images. What are images, first of all? So let's click on this button. Let's see what the images are. So the images are something by which Docker understands, okay, what it needs to set up its application and how it wants to set it up. So in images, there is some syntaxes about it, and we will going to cover it in some other session specific for Docker. But for this session, you only have to think of these as a minimum set of dependencies or minimum set of requirements required for single application to run in a container. And the container is runtime instance of an image. So always you have an image as a static content where you define like, okay, I want which particular OS I want. I mean, you just have to define in a file, and then Docker automatically read it and provide it with suitable resources so that when it create a container out of it, it will assign it that particular resources. That's it. So the images you can find in today's world, they're everything, whether it is a database, whether it is OS, whether it is, let's say, the Alpine image, you can see the Ubuntu image. So it's very easy. First of all, the Docker containers are very easy to scale. So today's world is about cloud, right? So why it's important? So Docker is important there. It's also important on your local setups, but it's more used on cloud setups, where you heard the terminologies like AWS, where you hear the terminologies like Kubernetes. Those things love Docker and containers. There are also Heroku containers, but that is something other concept. But again, underlying principle is same. Docker is also a company, and that provides this software to build your images, to build your containers, and so the Docker desktop is provided by that company. So you can read the documentation once you install it by going into this link and understand some basic commands of it. So you can just try these commands using Docker -- version, let's say. So let's check out our version, what is installed on my machine. So it is 18092, and you can follow these steps to understand what are the basic commands. So most common commands which we will use are like Docker pull, to pull some images from remote and to run it on our local, right? Then Docker ps -a or Docker ps, and what it is going to tell me is how many containers are running or stopped. So if you pass -a, it will also show you the stopped containers. But if you only pass like Docker ps, it is going to show you the running containers. So here you can see what is happening right now. On my machine, there are 3 containers running and 1 database is running, which is a MongoDB database. That is not for this session. It's just some container which I'm running on my machine. But there is something interesting over here, and we are going to talk about it in the next slides. But you just have to remember these common commands, and it's very easy if you're familiar with Git or running commands in shell. It's very easy. It's just a binary which executes these commands, and daemon understand it and do its job according to it. So what it is, how it works, this Docker PS will send an event to this daemon to tell me how many processes are running, related to the Docker containers, and then daemon spits this out. There is also a visual way to see it, and that is called Kitematic. It's a tool which you can use. It's also, you can download it via this option. So it will install Kitematic on your machine, and what it is, it's an application by which you can debug in your containers. So this is a view, and it tells you more about your containers. You can refresh it just one more time. So I just did Command R just to refresh on my local. And if you see, there are 4 containers what we have seen on the terminal, and it has more details about it. So what logs are running inside those containers, So this way, if I compare this view with this view, when you run this particular VM, you get very little details until you SSH into that particular VM and try to figure it out what's going on. But in this view, it also shows you, I like Docker because of its simplicity, first of all, and it's because of reusability. And that's where the today's world is focusing right now. So it's very pretty cool concept. Install it, try it out just to see what it works. This is just a view for us, okay? You can restart the container from here, stop it from here, or also you can do the same from via commands like docker stop particular container by its ID, right? And docker start, like that. Okay, so those are the basic commands about Docker and what we are going to use today. And let's see more reasons of why using Docker. So the fourth one is it's simple and reproducible setups. So what is reproducibility? If you are running a test, you want it to be reproducible if you find a bug, right? So that allows me to, so as you can tell very easily, if you are not using Docker at the moment, that sometimes you can relate this as, sometimes you figure it out that this is a bug on your machine, but on developer machine, it works perfectly fine, right? So why is that? Because developers install more resources or more dependencies than you sometimes, right? And because of that, since those are not installed on your machine, so you have no clue what's going on, and you are just wasting your time to figure out maybe it's an issue, maybe it's not an issue, right? So why then the Docker helps you. So imagine that your developer is also using the same process or same container which you are using, then the platform or the underlying setup required for your application will be similar, and that way you can easily reproduce the steps. And also the setup itself is very easy to start and stop, as we have seen from the commands. So that gives you the flexibility, and also it saves you a lot of time during debug and during the managing your all testing efforts. That's very important. I have used Docker since last 3 years now, and I can safely say that it helped me a lot. The next point is like Kubernetes, AWS, we already talked. If you are talking about cloud, it has to be containers. VM are no use in clouds. Then the last point is like it's easy to work with multiple versions of same application. So the best thing in Docker is like you can tag a particular. So this is a command. Okay, just forget about this thing at the moment, whatever it's saying, but just look at the colon and tag this name. Or let's go to Jenkins Docker image in on Docker Hub. Jenkins Docker Hub, and let's try to figure out what I'm trying to say. So uh, if you go into the tags section, so first of all, yes, Jenkins container, Jenkins running in a Docker container, and so it gives you already an idea, right? That where we are looking at. So Jenkins, we test our softwares there, and it's also using Docker. So as you can see, there is a tag section, and then you can create your application flavors. You can tag it with your versions of your application, and that means you can easily trace back or roll back if something breaks. So you can just pull that particular version and just start, like similar to Git, how the Git protocol works. Some commit broke, you just revert the commit. Same thing you can easily do if you know which particular tag broke this particular container, or which, if it is using this process or this process, you can easily figure it out using the tags. So that is my last point, what we discussed. And the next slide here, I want to discuss about some of its use cases which I have done, and it's very much now everybody does in testing, right? So first of all, more than 90% of applications out there are containerized. So everything is going in containers. Second, database testing. If you have worked on database testing or ETE, you know what the terminology is, I don't know, but the database testing is very tedious if, let's say, your application supports multiple versions or all of the industry provided setups. For example, my company supports all type of databases, whether it is PostgreSQL, whether it is MySQL, MS SQL, H2, Derby, Oracle, DB2, IBM DB2, and you know, each database also has its own versions. So that becomes the life as hectic if you want to test it one by one on a database, your particular data sets. So there you can easily use Docker containers to spin up multiple database versions or multiple upgrade, or these processes you can easily do with databases. You do the upgrade, you remove the container from your machine, and it's you can test, and you can easily reproduce it. So database testing is also a very important thing where we use this Dockerization. The third point is scalable. Selenium grid infrastructure in no time, which we are going to see today in the demo, how it is going to work with Docker and Selenium, right? Next is Jenkins CI/CD pipelines on Docker. That's where most of the people already use Docker. They when they hear it first time, oh, let's do it on Jenkins. So first experiment always starts with Jenkins, at least from what I've experienced. So let's Dockerize Jenkins processes, because the slaves, the build time, let's say your developer commits something, right, a code, and it takes around half an hour or 1 hour to run all the tests. Let's say for me, from my example, we have around 10,000 tests, roughly. And to run the execution on that scale, you need an infrastructure. You cannot run those tests on your own machine, because otherwise every time you try to start it or stop it, that's the day over for you. Right? And that's why you want to run it on Jenkins or in your CI pipelines, and most preferably we start with Docker, because there you can also reproduce them on your local. So that's where these are the common use cases, some of them. And let's jump on to the next concept which we are going to cover, that is the Selenium grid. So if you have attended the previous sessions and also looked into our YouTube videos, we have done some experiment with Cucumber, Selenium, Java, and we set up some common scenarios, right? Some feature files there, some fancy lines, and some code also. But now imagine I want to run that on some remote servers like Jenkins or on CI servers, when a developer commits something, I want to execute those tests, right? I don't want to constantly get feedback from developer, hey, did you commit? And then I start my testing on my local. No, I want to validate every commit which a developer does on master or whatever branches it is committing, or even if he creates a pull request. So there, the concept of Selenium Grid is you can scale out. Imagine you have thousands of tests. You have written thousands of end-to-end tests, right, for your application. Now, if you start those tests, they will execute, probably they will take a couple of hours to finish them, right? What if there is a possibility to parallelize those tests and run them on remote servers, right? And also, let's say those 1,000 tests you want to run on different browsers like IE, Chrome, Safari, Firefox, or mobile versions like iOS, Android, and the test cases are same or similar, but you want to run them on all those platforms. So do you imagine that you can run all of those tests on your local? No, simply no. You have to run it on a CI server and on Selenium Grid. So if you take a look at this picture, uh, it briefly explains how it works. So you have your test here, the test block. It pass some parameters to the hub. The hub is something, it's called, it is the central repository where he controls everything. Just imagine something like that. He's the king of these slaves. So these are the slaves. This is the king, and the king has information about whoever the slave um, is under him or her. So queen, right? So here you send some capabilities to this hub, and the hub take care of, okay, if you are asking to run this test, for example, on Firefox browser or Chrome browser, then which particular slave is available, first of all. Then if it is available, then it asks him to run the test and let me know when you finish. So the hub is just a switch where you send some commands and receive the response back. And when the test executes, I want to see the result over here. So the hub, when the test finishes in one of its slaves, provide and it get to know that, and then it sends it back to my test infra or test tool, whichever is running, and then it decides whether it passed, failed, like that. So this is the basic concept of Selenium Grid. The next thing, and we will see it in action first of all. The next thing, why Selenium Grid? We already covered it up, but let's cover the points. So first, helps execute a large amount of tests parallelly. The second is it drastically speeds up the CI time, right? And it's very handy when you have multiple teams. Let's say, imagine you have like 50 teams you are working in a bank, and you have like 10-20 teams, and each team has 4-5 people, agile process, right? So those people are committing in a day, they are committing like 1,000 lines of code, and now you want to test for every commit your test cases, right? All the test cases, all the regression which is going, regression test which you want to run against the master build, let's say, for example. In this case, now you will consider to run them parallelly and using Selenium Grid. So let's jump into how to run it using Zelenium. So what is this Zelenium? It's the capability to easily spin up Docker containers with Chrome browsers, with Firefox, and with all the dependencies required to run your Selenium test cases. And it also allows you, for instance, in some of the companies nowadays, people also use browser stack or remote cloud provided solutions for multi-browser testing. And you can configure Zelenium with that as well. You can configure Zelenium on Kubernetes as well, so that you can spin up thousands of containers on demand and run your test on top of them. And also, if it could not find the capability, or what is the capability? Capability is, if you remember the picture we discussed. So in this picture, the concept was like, we tell something to the hub that I want to run this test on Firefox. And just imagine that on Zelenium, the Firefox is not there. Just an example. then it can automatically redirect it. You can configure it to redirect to browser stack or some cloud providers. You can read the documentation and figure, it's very easy configuration, and you can it supports that as well. So but on a nutshell, let's start with how it works. So first of all, these three commands, just run this docker commands, docker pull, and first to download the Selenium Docker containers, which contains your browsers, then the Zelenium, which is your hub, and then the Selenium automatically connects to the container from Selenium to set it up your grid. That's it. That's the concept behind these three commands. So I already executed it. I'm not going to try it out because they're first time it takes some time to start, to download those images. But when they are done, you will see something like this. And I'm going to explain it a bit what this tells me. You are saying something like pulling, fs layer, waiting, pull complete, right? And this is the first command which I have tried. Sorry. Yeah. The first command I tried was docker pull value Selenium. The second command I tried here. I tried here, which is tossle Zelenium. Again, first, second. And the third command I tried over here. So I'm just running the container, and you have to go by sequence. So when you download this, it downloads some layers. And this is the beauty of Docker. So once you download something via Docker, that is, you download an image. Let's say you have two containers, two images. You want to run two different applications, but those two different applications use same layer. Layer is your let's say OS, right? So if both use Alpine Linux as their first command, so then Docker will automatically figure it out, and then it won't, because it already if it download it one time, it will not download for the other. So it will save space automatically, right? That's very handy when you want to run multiple things at once. And that is going to that is the main differentiator, one of the main differentiator from Docker and VM or virtual machines. So once you download it, you can also see here that some of the images like this one, as it's saying that this layer already exists. So maybe it is, yeah. So this is the first layer, right? So it downloaded this layer, and that's why it's saying here that it already exists. You don't need to download it again. So Docker automatically figure it out that what are the common things he knows and which is installed already on your computer, and that saves a lot of network traffic and also the resources, right, on your machines. The third part, these are the three commands. Once you executed them, this is the Selenium grids command. So when you do this start, which is this third command, it executes and it starts the Selenium grid, as you can see in the logs. And it also starts two nodes here. In the logs, as you can see, it says registering a node. And what is a node? Let's go back to our here. So as you can see in the node, you can, this is our slave, and where the test will get executed. And in this slave, you can install your browsers or whatever. So node is your container, and hub is another container which is talking to the container where the browsers are installed. That is our Selenium container. So that is the setup. And once that is done, you will see something like one is the dashboard, this dashboard. Second is live preview. So the next thing of test automation. I'm just going to start now executing the test, and then I'm going to discuss how it will look like. So in a test, let me explain what I did. So as I said, the original computer database website is down. So I created a sample feature file again, a separate feature file where the test scenario is this, where I want to search Facebook website. So I want to search website on Chrome, let's say, and I want to search website on Firefox, just to differentiate it. This is my scenario, and these are my steps. So I open Chrome, I open DuckDuckGo, I go for search for Facebook. I click my first link and I want to see the Facebook login page. That's my scenario. And this is my feature. Now I have the step definitions where it's pretty much same if you are following from the first two lectures, where we set up something in a before class regarding the drivers. Then I changed something. Now I commented where we were like on basis of condition, we were like checking if it is Chrome, then I want to use Chrome driver or I want to use Firefox driver. But this time we are using something new, which is called capabilities. So the capabilities which are used, which I talked about, is something that that hub understands. You know, now since now we are not running it on local, so let first run it on local. So I'm going to comment this out, and just to validate what is the difference, you know, in the end, what it will look like. So what I'm going to do is comment this out. So this is our basic setup, which we have already covered in previous lectures. So if I run this, and yes, and also just to add that we have not discussed it yet, but we are going to discuss it, the Cucumber features separately. That in Cucumber, you can also define tags. So like this, just annotate it with @ComputerDB or anything of your choice. And then you can say like here in the runner that I want to exclude those tests for now because they are not being used because the site is done. So I just want to run one particular duct feature in this case. So when I start this, it is going to execute only the duct feature for me. So let's see how it will behave locally. So it is going to start Chrome browser on my machine. Now see, I am not working right now, correct? Because the Chrome window is open and it's switching between the things and I cannot play with it. Now, what if I want to do some coding as well when the tests are running? It is going to switch my focus, right? Of course, you can run the test using headless mode or something like that, but still, this thing, if I want to see some in between my coding, how the tests are going and all, can there be a way? No, not easily. You need to configure a lot of things. But with Selenium or with Docker, let's see how it works out. So let's go back in our step definitions and uncomment and comment this stuff. So first, the desired capabilities for Chrome. And here I am also using, instead of Chrome driver, I am using remote web driver. Plus, this allows you to connect to a remote URL. And this URL is the hub URL. So it's pretty much understandable if you look at it. So here you won't get anything, but this is the hub URL where you send the information. And it's pretty common across your setups. If you are using browser stack, you also append URL of browser stack here in the URL. But that's not for this session. Let's now take a look at how it will work out. So now the test will be executed somewhere here in the Selenium grid. So let's see the magic. Start the test again. And let's jump back here. So when the test starts, yes. So as you can see, the Chrome browser first launched here. Let's also interact with it. So you can also open it in detail mode, or you can also see the second test now, since it first one completed. So it now running on Firefox, if you see it here. So now the test is executed on two different browsers and are executed silently, right? And I can also work with my machine. So I'm not stuck, test is passed, and the same thing, same behavior is reproducible on your machine and on your developer machine, thankfully to Docker. So that's the magic. You just change these three things, or minimal change, and now you are running on your local and on your remote servers. Let's say you can also pass different commands to run them parallelly, which we will discuss later. But the concept here is same. But in the logs, let's see. I want to see how the magic happened, right? Because how this worked out. So first, when we started the grid, it created a request. It received a request from my test. in the log, as you can see, it receives a request that I want a browser with Chrome, and I not pass the version, so he will just pick up the latest. But just imagine that if you have two Chrome versions, here you can see the browser versions, right? And this is, let's imagine you want to test with multiple types of Chrome versions. So that you can also do it here. So you can also set it up like multiple nodes. You can tell Selenium to spin up 3 containers with Chrome this version, right? Or the 2 containers with Chrome this version and Firefox that version, something like that. The commands are available in documentation. You can read it out, you can play with it, and get a gist of it, how it scale. So this is a live mode. Let's head back to dashboard view, because here, uh, as you see, it out of the box gives you something, which is your video recording of your test. So this is saved. So this is my test, which executed right just now. You can see the timestamp here. So this is my test, and what went wrong, and also the logs. So one is Selenium log, and the second is browser driver log. But it's only when you understand Selenium fully, you will can see that whether it is reaching, whether it is creating a session with that capabilities or anything like that, if I'm passing the right capabilities or not, something like that. But for time being, the sufficient thing is videos. Now, okay, how can I share this video to a developer if this fails? So you can just send this video by, so it if you look at the command, it mounts a volume. Now a volume is something where you tell Docker container, since Docker container is a process, right? So you tell Docker container that I want to map one of my device volume to you, so that you can save something in it. So in this volume, it saves, this is the left part is my local volume, and right part is the volume inside my Docker container. So I can head back to that volume and take my videos and share it with the developers like that. So this is my video MP4 file, and you can share it as an evidence, whether it's completed, whether it failed, something like that. And it gives you more control. You can see, like, you can work on your machine while the 10 tests are running and you are not stuck. You can anytime switch your windows and see how the test, how it is working, and you can debug it easily as well. You can interact with the container. You can play with the browsers as well. When you interact, you can play as well. That's also one of the nice feature in this case with Selenium. And it gives you flexibility to do everything what you do locally. So nothing different. But with minimum set of change, you are running now your test on a grid. This is our Selenium grid. Now, the question is how it can scale. So you can read the documentation. In the documentation, there are parameters like you can pass a number, how many I want, or you can also configure on Kubernetes. That is pretty advanced concept at this moment, but the documentation is pretty rich. You can follow it. Steps are very simple if you understand Kubernetes, and it will just set up your infrastructure on your infrastructure very easily. So that's whole about Docker introduction and a bit about um, Zelenium or Selenium grid introduction. So that is it. Thank you.